Hello, this is JosiahKerley, and today I'm going to be giving a lightning talk on Virt-Maker. Virt-Maker is a disk image building tool for GNU Linux that uses snapshots for aggressive caching and fast turnaround using simple procedural code. In traditional virtual machine infrastructure, you may find yourself manually installing an OS for golden image creation just as you would on bare metal, but the problem you run into is inconsistent manual builds and wasted time, even when cloning from templates. Virt-Maker provides a way to define input sources such as generic cloud images, VirtBuilder images, or even ISOs. This can provide quick and consistent parametric builds using a simple and readable YAML syntax. Virt-Maker specs are like blueprints that automatically build traditional VM images, cloud images, and even source images for disk-based bare metal deploying or even booting from iSCSI. It is a free and open source CLI tool and is written in Python and can be installed into most distros like Ubuntu or Enterprise Linux with just a few steps. For this demo, I'll be running in Podman using the official Rocky 9 image. Once inside, I'll install EPEL, then I can install the prereq RPM packages that'll get us up and running. Next, I will install the latest version of Virt-Maker directly from GitHub. Once installed, I'll create our first spec file, and I'll call it Virt-Maker.yaml. At the top of this file, I'll begin the spec with an import. Importers are how we pull in source data. In this example, I'll be using the download importer to fetch the Rocky generic cloud image. Next, I will have it perform some customization steps. For the first step, I will install the neofetch package onto the snapshot. This will use virt-install to automatically detect that the image is an RPM-based system and will run the appropriate installation command within a root. Then, I will have it set a hostname within the snapshot. Finally, I will export the image as a QCOW2. Exports are how we take the build we performed and write out the disk image to a file. In this example, I'm using the QCOW2 exporter. Now we're ready to build. I'll kick it off by issuing Virt-Maker build with the file Virt-Maker.yaml that we just created. Once it starts, it checks to see if any of the steps have been cached. Since this is our first build using that cloud image URL, it will reach out and pull it down into the cache. Now that the import is complete, it will begin the customization steps. We see it begins to install neofetch. However, it fails to install. It correctly identified that it should be using the DNF command, but the neofetch package is not available in the standard repos as shipped. So, let's hop back into the Virt-Maker YAML file and install EPEL first. Once again, we kick off the build, and since the cloud image is already in the cache, we don't need to download it again. EPEL installs successfully, and now it moves on to attempt to install neofetch again. And success! The build finishes, and as its final task, it exports the QCOW image as lightning.qcow2. So let's make some more changes. Here, I'll go ahead and install a few more packages. We kick off the build again, and since the snapshot where EPEL is installed completed last time, it can skip that step. But since the step where we install neofetch, vim, and nano has changed, we have to rerun from then on. Now that it completed, it overwrote the old image with a new build. Let's make another change. Let's update the hostname. On the hostname step, I changed the value from lightning.local to lightning.mcqueen. This time when we build, it skips the second package install step, and the only change that has to happen is the hostname change. This means that instead of having to wait a few minutes for the whole system to rebuild, we can have a freshly minted appliance in less than 30 seconds. And if we make no change at all and run the build again, it exits almost instantly since there's no new changes. This is the power of the caching. When that concept is understood, it becomes clear what the real value is: printing out consistent appliance images as fast as possible. Another feature of Virt-Maker is parametry. We can define parameters within the YAML file that allows the use of variables, and in combination with Jinja 2 templates, we can greatly simplify the customization of appliances. Here, I will parameterize both the hostname and the export path of the QCOW2 image. Once the build is run again, we set that the file name that we were exporting has changed. Since in this example the hostname and file name is parametric, we can pass params to the build command that will mint a new appliance without having to edit the file at all. We can even combine shell tricks to build a whole army of custom disk images if we wanted to. This allows easy integration into CI/CD pipelines. For example, when a requirement such as setting SELinux to permissive comes down, a single line change can be made and the whole pipeline can be kicked off again, producing fresh appliance images completely automatically. One last thought I wanted to leave you with is with the templating. Since any value can be evaluated as a Jinja template, you can build fairly sophisticated specs. Here in this example, I'm creating a parameter for host file entries and using Jinja to write out the text file. To wrap this up, Virt-Maker is a powerful tool that enables efficient automation of disk image creation for GNU/Linux appliances. Its YAML syntax, caching capabilities, and parametric features make it an ideal solution for streamlining the image build process. By utilizing Virt-Maker, you can significantly reduce the manual effort and increase consistency in your appliance images. This is particularly useful in CI/CD pipelines where rapid deployment is critical. With its flexibility and utility, Virt-Maker is a valuable addition to any development workflow, allowing you to build faster and more effectively. Thank you for joining me in this lightning talk, and have a good day.